Hello everybody and welcome to this video today. In this video today, friends, we shall be looking at how we can solve this our differential equation we have here on screen, namely guys dy by dx equal to 1 over e raised to the power 4x plus 3x. We've been given the condition that f of 0 is the same like 0. Great. So friends, please don't forget to like this video, subscribe to the channel so that we can have so many subscribers to progress in that light. Thank you very much, friends, and don't forget to share the video out with your friends. Share the video out to them so that they can have access to contents like this that are going to help them. Great. So friends, let's start with our problem today. Great. So friends, according to this our differential equation, we see that the best form in which we always want to solve almost all our differential equation is always to have it of the form dy by dx plus f of x times y equal to g of x, where f of x is a function of x, y is y remains y, which is the same like g of x is also a function of x. Great. So friends, according to what we have here, I don't think it is possible for us to get this part right, f of x times y. It's not possible for us to have y right, because at this point in time, with this dy by dx in place, it is not possible to take down this y right. Good. So friends, what do you think in this case? What do you think at this point in time, friends? You can pause the video and try it by yourself for greater understanding. Just pause the video, friends, and give that a try. Done? Great. So friends, this is where I got stuck. I saw that it is not possible for us to bring that y down and keep in mind, friends, keep in mind that we are dealing here with dy by dx. So friends, since we cannot force this y to come down so that we can have it in this form, don't you think we can make use of this x? Great. So what if we wrote this equation in such a way that what we have here is instead f of y, then what we have here is x, then here is y. Check this out, friends, check this out. In that case, guys, in that case, we will not longer want to have dy by dx rather, but we want to have now but dx over dy. Great. We will now want to have now, guys, but dx over dy. So if we invert all through, we are going to have dx on dy. Likewise here, we invert, we are going to have e raised to the power 4y plus 3 all over 1, but the 1 doesn't matter, so I simply take it out. Right. Good. So friends, you can see that this is our equation. Now if we simply take 3 to the left hand side, we are going to have dx over dy now minus 3x equal to 4 equal to e raised to the power 4x and 4y. Yeah, sorry friends, e raised to the power 4y. Good. So friends, you can see that it is now of the form now of dx on dy plus now a function that has to do with y times this our x, which is now the same like what g of y, which is a function of y, right? Because this is our dy by dx, we have it. This is our dx by dy, we have it here. Then we have our f of y in this case, guys, is what is negative 3, right? The x, we have it. Then g of y, this is a function of y. Perfect. So friends, I think everything is done, right? Wait, everything is as what we have, right? Cool. So in this case, guys, how then can we solve this our problem? How then can we solve it, guys? Is to look for an integrating factor, right? So this is the same problem that we have here. So friends, to solve this our problem now, it is now of this form, right? We can now use a suitable integrating factor, right? So we're going to have our integrating factor if, which is now the same as e raised to the power the integral of f of y. What is f of y in this case now, guys? It is what? Negative 3. Good. So we're simply just going to have if the same like e raised to the power the integral of f of y is equal to what? Negative 3. Then now we end with dy because we're integrating now with respect to y. Great. So guys, integrating negative 3 in the y world simply gives us what? Negative 3y. So our integrating factor now turns out to be e raised to the power negative 3y. Friends, we all know that when we are done integrating, we put on a constant, right? But in this case, guys, forget the constant, okay? Don't bother about the constant in this case. It is regarded to be 0. Great. So friends, Having this our integrating factor, now what we need to do now is to take the integrating factor and multiply it with this our equation here. Okay, this our DE. Take the integrating factor and multiply it by all of this our DE. Friends, keep in mind that for us to have the integrating factor to be something like e raised to the power the integral of f of y dy, what should be in front of this our dx by dy has to be 1. Okay, if it is a constant other than 1, you simply divide by that constant. Okay, if it is -1, you simply divide or multiply by negative. Okay, so what must be in front of dx by dy or dy by dx in this case must be 1. It must be 1. So like I said, friends, in this case now all we need to do is to take the integrating factor and multiply everything by the equation. So that is going to be in an exact form. So we are going to have it here like this. We multiply by it. So if we distribute it now, if we distribute e raised to the power -3y, friends, we are simply going to have e raised to the power -3y dx by dy minus 3x e raised to the power -3y. Then guys, you multiply this by this, you see that the bases are the same, indices comes in. We are going to have 4y minus 3y, which gives us y. So we have e raised to the power y. Good. So friends, we can now see that this our DE now is exact, right? It is in a form that has made it to be exact. Good. So we can therefore write the left hand side of this our DE, this left hand side, we can recognize it as what, guys? As the derivative with respect to y of x e raised to the power -3y. Why? Because if we differentiate x with respect to y, we're going to have a dx by dy, right? Keep e raised to the power -y constant, that's why we have it here, plus now keeping x constant, differentiating by the multiply by the derivative of e raised to the power -3y. We simply keep the -3 down, then we multiply by the same function, which is e raised to the power -3y, and this guy stays the same. Good. So we can say that everything on the left hand side now therefore translates into this our derivative of this function that we have here. So in this case, guys, we simply separate the variables. We are going to have the derivative of x e raised to the power -y equal to e raised to the power y dy. So now we therefore integrate both sides. Now integrating both sides, friends, integrating the derivative of something simply gives us that thing. As you all know, guys, we are integrating e raised to the power y with respect to y. E raised to the power y, friends, as you all know, it never dies. Great. So we are simply just going to have x e raised to the power -3y equal to e raised to the power y, which it never dies when integrating or differentiating. Then now plus c, we are not integrating, we put for the constant plus c. But friends, keep in mind that we have our initial condition here that f of 0 is equal to 0, right? Good. Therefore means when x is 0, y is also 0. Good. If we put x to be 0 here, everything becomes 0. Put y to be 0 here, we are going to have 1. Put it to the left hand side, we are going to have what? C to be -1. Good. So we have c to be -1. So now we simply bring c to be -1 into this our equation, into this our equation. We are now going to have and divide all through by -3, and divide all through by e raised to the power -y. Good. Because we are going to input this our cs with -1, and we divide all through by e raised to the power -3y. So we are going to have this, because c is -1, e raised to the power y stays the same. Now friends, we see that we could simplify further. This we can do e raised to the power y over e raised to the power -3y. Indices comes in now, and we can also do -1 over e raised to the power -y, right? Good. And indices as well comes in. So at the end of the result now, if we solve so well, guys, we are going to have our answer to be as x equals to e raised to the power 2y minus e raised to the power 3y. Great. So friends, this is the solution to our differential equation. Keep in mind, friends, that in this case now, x is now a function of y. Okay, x in this case is a function of y, not y being a function of x in this case. X in this case is a function of y. Great. So friends, thank you for watching the video, and don't forget to like the video, friends, because it took me a lot of time to set up all these slides to make up this video, friends. It took me a lot of time and a lot of energy. So friends, all I ask of you is just to press the like button and subscribe to the channel if you've not done so, and please share the video with your friends. Thank you very much, and see you in my next video. Meanwhile, friends, feel free to reach out to me. If there's something you didn't understand, just put in the comment section and I'll explain again very well. Thank you guys and have a blessed day.